In this video, we're going to talk about three definitions. The first one that we're going to bring up is relation. A relation is a set of ordered pairs. Relations are a little hard to describe in math because there are many ways we can write a relation to a person. The first and nicest way that we could see a relation is exactly how this definition is stated, as a set of ordered pairs. A finite set is probably the nicest one. A finite set has exact, like a single number. It doesn't go on forever. So in this situation, let's say we have a set and we got -5, 2 as an ordered pair. We got 0, 3 as an ordered pair. And let's do one more. How about 1, 10 as an ordered pair? So this relation is finite. It's just 3 sets of ordered pairs, and that hits the definition on the nail, set of ordered pairs. Now, the next definition that we're going to explore, we'll explore more relations, hold on. The next one that we're going to talk about is domain. Domain is the set of all the first components of the ordered pairs. So, when we're looking at domain, essentially what we are going to be looking at is the first components, which is a fancy way to look at all the x coordinates. So we're going to look at all the x values for our domain. And when we look at it, we got -5 here, we have 0, and we have 1. Because it's a finite number and we're just listing them, the easiest way to list them is to put it into set notation. And the same idea will be done for our range. Range is the set of all the second components of the ordered pairs. So for us, we're going to be looking at range, and we're going to be thinking about the y values. And because it's a finite set, it's really nice to just go ahead and list them in this set notation. We got 2 is the first one, 3, and we also have 10. And there's the range of this relation. Now you're probably going, okay, that was really nice. Let's see something a little bit worse. I'm glad you're asking from over the computer in a different time in the future. So let me provide you another relation. Let me make it a little bit longer. Still a finite relation just to get used to it. Let's say we got -1, 5. We have -3, 6, we got 0, 7, 5, 12, and let's do one more for good measure because I got a little bit of space here. How about 7, 9? All right, so these ordered pairs have some sort of relation, be it nice or not. In this case, it's definitely not linear. We are going to go ahead and look at this relation and find its domain. So when we are looking at the domain, another way you can think of it is the input. It's the x values that we put in. That's where we start with when we plot these points. Domain is kind of like the beginning for all of our relations. And again, we have set notation because it's a finite set. It's really nice to just list them off. And you're going to see that I'm just going to list them as I see them. So I start with -1, -3, 0, 5, and 7. Yes, this is not in order. You are more than welcome to go ahead and change it where that -3 is first and put it in ascending order. But it's not too big of a deal because when we put things in set notation, we're just listing off values. Same idea with the range. The range you can think of as the y values or the output, what we get out of our relation. And those are the second components. Again, you can list them how you see fit. I'm just going to list them as I see them. And there's our range. Ooh, my curly bracket got a little weird there. And that is all.